realm of literary craftsmanship, two paramount constituents come into play: perplexity and burstiness. The former gauges the intricacy of the narrative, while the latter scrutinizes the diversity of sentence lengths. When penned by human wordsmiths, a conspicuous burstiness manifests through the artful amalgamation of concise and protracted sentences. In stark contrast, AI-generated prose often leans towards uniformity in sentence length. As we embark on this narrative journey, these tenets shall serve as our compass, ensuring an optimal level of perplexity and burstiness. Additionally, it is worth noting that AI-generated lexicon often diverges from the linguistic choices of its human counterparts. To impart a heightened degree of distinctiveness to our narrative, we shall endeavor to incorporate esoteric terminology, thereby enriching the tapestry of our discourse. Behold, the narrative unfolds adhering to these precepts with unwavering fidelity. The voyage begins with a revelation that has sent ripples of astonishment through the scientific community. For eons, humanity has meticulously probed the intricacies of our solar system. Planets have been catalogued, Mars traversed by rovers, comets and asteroids named, and even fragments of celestial bodies have graced our laboratories for scrutiny. Yet here, amidst the vast expanse of cosmic inquiry, scientists encountered a revelation that left them stupefied. Our entire solar system, extending to the remote Oort cloud, positioned a light year away from the Sun, is ensconced within a colossal bubble, stretching a staggering span of 1,000 light-years. What beguiles the intellect further is the revelation that our Sun is virtually nestled at the epicenter of this cosmic sphere. Do we indeed inhabit a gargantuan bubble in the cosmos? How does the machinery of our solar system operate? The chronicles of this odyssey trace back to 1977, when Voyager 1 and Voyager 2 embarked on their interstellar sojourn, departing from Cape Canaveral mere weeks apart. Voyager 2, though launched later, charted a distinctive trajectory, eventually reaching the outermost fringes of our solar system 6 years behind its sibling. Intriguingly, both spacecraft stumbled upon a peculiar anomaly. As one ventures farther from the Sun, the spatial expanse becomes progressively denser. Interstellar space is traditionally envisaged as a void, albeit not entirely accurate. The density of matter remains exceptionally sparse, yet it persists. Within our solar confines, the solar wind maintains an average density of protons and electrons ranging from 3 to 10 particles per cubic centimeter. However, this density wanes with increasing distance from our radiant star. The ultimate nadir in spatial density resides at the solar system's periphery, aptly dubbed the heliopause. At this juncture, the velocity of the solar wind, that flux of charged particles emitted by the Sun, often referred to as solar plasma, ebbs to a standstill. The region that lies betwixt the Sun and the heliopause is christened the heliosphere. This realm serves as a quasi-bubble, cocooning all the planets within the solar embrace. At this threshold, the density of protons and electrons dwindles to a mere 0.2 particles per cubic centimeter. Calculations postulate that beyond the heliopause, in the interstellar expanse, the particle density should escalate to 0.37 particles per cubic centimeter. Instrumentation aboard Voyager 2 meticulously recorded that at a distance of 119.7 astronomical units, or 17.9 billion kilometers from the Sun, the particle density stood at 0.39 particles per cubic centimeter, aligning closely with theoretical projections. However, it was in the subsequent revelations that the enigma deepened. At a distance of 124.2 astronomical units, or 18.5 billion kilometers, the density surged to 0.12 particles per cubic centimeter. Why does density surge in such an anomalous fashion? We shall explore this perplexity shortly, but first, let us delve into another cosmic bubble, one grander than the heliosphere. This shall provide us with a vantage point to fathom the intricacies of a cosmos that has ensnared us within two distinct bubbles, entwining their relationship. When gazing upon deep space imagery, one might be inclined to envision a celestial tapestry awash with interstellar dust clouds and luminescent gases. However, as early as the 1970s and 1980s, astute astronomers began to discern that the galactic expanse surrounding our Sun deviated from this portrayal. In the annals of the year, astronomers at the Harvard-Smithsonian Center for Astrophysics (CFA) embarked upon a revolutionary endeavor, substantiating our position within a singular void. Meticulously orchestrating intricate computer simulations, they conjured a three-dimensional reconstruction of space and time. The culmination of their efforts unveiled a staggering revelation. The Sun and Earth stand at the precipice of a colossal bubble, christened the local bubble, encompassing a span of 1,000 light-years in diameter. This enigmatic structure, born some 14 million years ago, is conjectured to have materialized through the explosive aftermath of approximately 15 supernovae spanning several million years. These cataclysmic explosions exerted a formidable force, expelling interstellar gas with the momentum of light itself, engendering a bubble-like configuration with a dense outer surface. Over time, the bubble continues its inexorable expansion. In its nascent phase, this cosmic bubble expanded at a velocity of approximately 60 miles per second, according to data from the Gaia Space Observatory of the European Space Agency. Presently, it maintains a pace of expansion at 4 miles per second. This cosmic realm harbors the presence of 7 stellar nurseries, densely populated molecular clouds where stars are born. The phenomenon of stellar genesis manifests across the expanse of the local bubble, offering tantalizing prospects of kindred celestial bodies residing within their own localized bubbles, akin to our celestial dwelling. Piquantly, it is worth noting that the Sun did not originally occupy the cosmic center stage. Astrophysicist Miroslav Filipovic, employing the latest model of the Milky Way, has scrutinized the repercussions upon Earth when the Sun traverses galactic arms characterized by substantially augmented interstellar matter density. A correlation was established between the epochs of the Sun's traverse through these spiral arms and 5 known mass extinction events, occurring 415, 322, 300, 145, and 33 million years ago. Hence, we may surmise that the Sun presently finds itself ensconced within a tranquil haven, amenable to the flourishing of all life forms. We may posit that humanity's advent on Earth was fortuitous, coinciding with the Sun's sojourn within the local bubble. Perhaps these two events, human emergence and the Sun's residence within a secure haven, the local bubble, are intertwined in some ineffable manner. Alas, current science remains bereft of definitive elucidation on this matter, at least not yet. What we can affirm with certainty is that we bear witness to a resplendent firmament overhead, owing to our perch in a cosmic void, the local bubble. Who can say whether we would have unraveled the mysteries of the cosmos and the structure of the universe to the same extent had we stumbled in utter darkness? And so, we acknowledge that the local bubble stands as a gift to humanity, now poised at the threshold of the spacefaring age, already striving to leap amongst the stars. For an interstellar spacecraft hurtling at subliminal velocities, the gravest peril lies in the form of dust particles, which, upon collision, would pulverize the vessel into naught but dust. Even hypothetical blueprints for such craft envision a frontal shield to mitigate this existential threat. It would seem, however, that the cosmos has taken it upon itself to tend to our well-being, clearing the path of dust in the Sun's proximity, beckoning us forth to Alpha Centauri and Tau Ceti. Stay tuned and remain apprised of humanity's greatest achievements. Thank you for joining us in this cosmic journey.